Good morning. Welcome back to the session. See, in the last class, we were discussing about zero order reactions and first order reactions. Now, what do you mean by zero order reaction? Zero order reaction means it is a chemical reaction in which reaction rate it is directly proportional to concentration of the reactant power it is 0, or it is a chemical reaction in which reaction rate it is directly proportional to 0th power, directly proportional to what? 0th power of concentration of the reactant, or rate of the reaction it is independent of concentration of the reactant. Such a reaction it is called as zero order reaction. Example for zero order reaction, that is reactions taking place on the catalyst surface and also enzyme catalyzed reactions and reactions taking place on the catalyst surface. They are examples for zero order reactions. So next we derived integrated rate equation for a zero order reaction. What is that integrated rate equation? That is K it is equal to R naught minus R by what? By T, where R naught it is the initial concentration of the reactant, R it is the concentration of the reactant remaining after time T, T it is the time in seconds. Okay, so K it is equal to R naught minus R by T. This is the integrated rate equation for what? For a zero order reaction. Next we went to first order reaction. Definition of first order reaction, it is a chemical reaction in which reaction rate it is directly proportional to concentration of the reactant power it is 1, that is rate it is directly proportional to concentration of the reactant power it is what? Power it is 1. So first order reaction can be defined as it is a chemical reaction in which reaction rate it is directly proportional to first power of concentration of the reactant. Such a reaction it is called first order reaction. See, example for first order reaction, one is decomposition of N2O5 dinitrogen pentoxide. Other example, that is hydrogenation of ethene. So decomposition of N2O5, hydrogenation of ethene, they are examples for first order reaction. We derived the expression for K, or integrated rate equation for first order reaction, that is K it is equal to 2.303 by T log R naught by R. So integrated rate equation for a first order reaction, that is K it is equal to 2.303 by T log R naught by R, whereas for zero order reaction we have K it is equal to R naught minus R by T. So these things we studied it in the last class. Today we are going to define half-life period of a chemical reaction, or we are going to study about half-life period of what? Of a chemical reaction. Let us define this term half-life period. See, half-life period it is defined as it is the time. You can see the symbol here, T half. So it is what? It is the time. Half-life period it is nothing but what? It is nothing but time in which the concentration concentration of the reactant is reduced to half of its initial value. I'll repeat it once again. Half-life period, it is defined as, it is the time, it is what? It is the time in which concentration, molar concentration of the reactant, it is reduced to exactly half of the initial value. For example, I'll take a general reaction, reactant A producing products. Let the initial concentration, that is when time t equal to 0, let the concentration of the reactant, let it be equal to 10 gram. Let it be equal to what? Let it be equal to 10 gram. See, we know that in a given chemical reaction, concentration of the reactant will be high in the beginning. That is when time equal to 0, concentration of the reactant will be maximum. As time progresses, concentration of the reactant goes on decreasing, correct? 10 gram will be reduced in the next time interval. So, when t equal to 0, let its value be 10 gram. As time increases, this amount should undergo what? It should undergo reduction, correct? So, concentration of the reactant goes on decreasing with respect to time. At one stage, it will be reduced to 5 gram. It will be reduced to what? Reduced to 5 gram. 5 gram means what? It is exactly half. 10 by 2 it is 5, correct? So, what is the time required for reducing 10 gram to 5 gram? Or if I take initial value as 2 gram, then 2 gram must be reduced to 1 gram. So, exact half. Or if I take 1 gram, it should be reduced to 0.5 gram. So, initial value must be reduced to exactly half. If it is 10, it should be reduced to 5. If it is 2, it should be reduced to 1. If it is 1 gram, it should be reduced to 0.5. So, what is the time required for this reduction? This time, it is called as what? It is called as half-life period. So, half-life period means it is the time in which initial concentration, it is reduced to exactly half. Initial concentration, it is reduced to what? Exactly half. Or it is the time required, it is what? It is the time required for 50% completion of the reaction. Time required for what? 50% completion of the reaction. That time, it is called as what? It is called as half-life period. Say half-life period, it is designated as either T half, symbol used for half-life period, it is T half, or we can write T 0.5. We can write what? T 0.5, or I can write T 50%. T 50%. T 50 means time required for 50% completion. Time required for what? 50% completion. So, that time it is called as what? It is called as half-life period. Let us repeat it once again. Definition of half-life period. See, half-life period, it is the time, in that time, molar concentration of the reactant, molar concentration of the reactant will be reduced to exactly half. Molar concentration will be reduced to what? Exactly half. That time, it is called as what? It is called as half-life period. We shall continue. Now, next, what we are going to do is, we are going to derive the expression for half-life period in the case of zero order reaction as well as first order reaction. Let us derive the expression for zero order reaction, half-life period expression for what? For zero order reaction. See, for a zero order reaction, for what? For a zero order reaction, we have the expression that is K it is equal to what? R naught minus R by T. K it is equal to R naught minus R by T. What is R naught? R naught, it is the initial value, R it is the concentration of the reactant remaining after time t. After what? After time t. So, K equal to R naught minus R by what? By T. See, when will use the condition when t equal to t half, that is first half-life period. So when t equal to t half for a first half-life, initial concentration, that is R naught value, will be reduced to half, correct? So initial value it is R naught. When time t equal to t half, R naught will be reduced to what? Reduced to R naught by 2. So hope you can understand. See, this is the initial value. Initially we took R naught, correct? Initial concentration it is R naught. When t equal to t half, means for the first half-life period, this R naught will be reduced to half. So initial value is R naught, it is reduced to half, means remaining value is R naught by 2 only. So concentration of the reactant remaining, it is equal to R naught by 2, correct? So R means concentration of the reactant remaining. What is the amount of the reactant left out? Amount of the reactant left out, it is equal to R. It is equal to what? It is equal to R naught by 2. Initial value by 2. Let us substitute this value in the expression 1, first expression. So I will substitute it here. See, K it is equal to what? R naught minus R. What is the value of R? R it is equal to R naught by 2. It is what? R naught by 2 divided by T. What is T? T it is equal to T half. T it is equal to what? T half. R naught minus R naught by 2. It is equal to how much? This one I will take it as 1, correct? 1 minus half R naught, correct? 1 R naught, this is half. 1 minus half, it is half only. So it is equal to 1 minus half, it is half. So it is equal to R naught by 2 by what? By T half. So K it is equal to R naught by 2 divided by T half, or here I can write T half it is equal to cross multiply, that is R naught divided by 2K. R naught divided by what? R naught divided by 2K. So T half for a zero order reaction, it is equal to R naught by 2K. What we can say here in this expression? See, half-life period, it is what? It is directly proportional to initial concentration. Directly proportional to initial concentration. It is inversely proportional to the rate constant. Inversely proportional to what? Inversely proportional to the rate constant K. So half-life period of a zero order reaction, it is directly proportional to initial concentration, inversely proportional to rate constant K. See, for the exam, they will ask the question like this: show that half-life period of a zero order reaction, it is directly proportional to initial concentration. It is directly proportional to initial concentration. I will repeat the question once again. So show that half-life period of a zero order reaction, it is directly proportional to what? Initial concentration. If they ask the question like that, you have to derive this relation, that is K equal to, you have to take the integrated rate equation, K it is equal to R naught minus R by T. Use the condition, that is when T equal to T half, that is for the first half-life period, means for the 50% completion, remaining value will be R naught by 2. Initial value it is R naught. Amount of the reactant left out, it is equal to how much? It is equal to R naught by 2. Substitute the values in the expression. So we get K it is equal to R naught minus R naught by 2 by what? By T half, correct? R naught minus R naught by 2 divided by T half. This is 1 minus half, correct? So 1 minus half, it is half only. So it is equal to R naught by 2 by what? By T half. By what? By T half, or T half equal to R naught by 2K. So half-life period of a zero order reaction, it is equal to R naught by 2K, or it is directly proportional to initial concentration, inversely proportional to rate constant. Study this derivation properly. Important. See, next we are going to derive the expression for half-life period in the case of first order reaction. We are going to derive what? We are going to derive the expression for half-life period in the case of what? In the case of first order reaction. See, for a first order reaction, for what? For a first order reaction, we have, here I can write, we have K, it is equal to 2.303 by T, 2.303 by T log, it is log R naught, log R naught by R. K equal to 2.303 by T log R naught by R. So, this is the integrated rate equation for what? For a first order reaction. I will use the condition, half-life period condition. See, when T equal to T half, when T equal to T half, that means for the first half-life, concentration of the reactant, that is R value, will be reduced to exactly half. Initial value is R naught, it is reduced to half, means remaining value it is R naught by 2, correct? R naught by 2. So, when T equal T half, R equal to what? R it is equal to R naught by 2, that is it is reduced to half of the initial value. Initial value is R naught, so it is reduced to half, means R naught by 2. Substitute the values here in the above expression or expression 1. So, K equal to 2.303, it is what? 2.303 by T. What is the value of T? T it is equal to T half. Value of T it is what? T half log R naught by R. What is the value of R? R value it is R naught by 2. R naught by 2, correct? So, R naught divided by R value is R naught by 2. R naught cancels out, 2 will be, 2 I have to write it where? 2 I have to write it in the numerator, it will go to the numerator. So, K it is equal to 2.303 by T half, that is log 2. 2.303 by T half log 2. What is the value of log 2? See, value of log 2, it is 0.301. I will continue it here. So, K it is equal to 2.303 by T half, value of log 2, it is 0.301 or it is 0.3010, multiply. So, K it is equal to 0.693 by what? By T half. K it is equal to, on multiplying we will get what? 0.693 by T half, or T half it is equal to 0.693 by K. 0.693 by K. So, this is the expression for half-life period of what? Of a first order reaction. Observe this expression properly. See, in this expression, there is no initial concentration term. Can you see R naught value here? No. So, T half it is equal to 0.693 by K, means expression for half-life period in the case of first order reaction does not contain any initial concentration term. Does not contain any initial concentration term. So, what I can say? Half-life period of what? Of a first order reaction, it is independent of initial concentration. Half-life period of a first order reaction, it is what? It is independent of initial concentration, because expression for half-life period does not contain any initial concentration term, that is what? That is R naught. We can't see any R naught value here. So, half-life period, it is what? It is independent of initial concentration. In the exam, they will ask the same thing. Show that half-life period of a first order reaction, it is what? It is independent of initial concentration. That will be the question in the exam. So show that half-life period of a first order reaction, it is independent of initial concentration, or directly they can ask, show that T half equal to 0.693 by what? By K. Show that T half equal to 0.693 by K. So we completed both the derivations. I will write the expressions once. See, for a zero order reaction, T half, it is equal to R naught divided by 2K, or what I can say, T half, it is directly proportional to initial concentration, directly proportional to initial concentration. For a first order reaction, we have T half, it is equal to 0.693. T half equal to 0.693 by K. So for a first order reaction, it is 0.693 by K. For a zero order reaction, T half equal to, it is R naught by 2K. So this expression does not contain any initial concentration term. So T half, it is what? It is independent of what? Initial concentration term. Independent of what? Initial concentration term. Suppose if I continue like this for second order, third order reaction, at the end, for a general reaction, I can say, or generally, T half, I can write it like this, it is inversely proportional to initial concentration term power n minus 1. Power it is what? N minus 1, or I can write T half, it is directly proportional to initial concentration term power 1 minus n. Power what? Power 1 minus n. So half-life period, it is inversely proportional to initial concentration term power n minus 1, or half-life period, it is directly proportional to initial concentration term power what? Power 1 minus n, where n represents order. N represents what? N represents order. Substitute the value of n. Once we can check it. See, substitute the value of n. What is n? N, it is the order of the reaction. See, for a zero order reaction, what I have to do is I have to substitute n equal to 0 here. Substitute the value of n. It is equal to how much? It is equal to 0. So when I substitute n value as what? As 0, it is 1 minus 0. 1 minus 0, it is what? 1 minus 0, it is 1 only. So T half, it is directly proportional to R naught power 1. R naught power 1, or it is R naught only. So T half, it is directly proportional to R naught. Correct. So for a zero order reaction, T half, it is directly proportional to R naught. Let us check it for first order reaction. First order reaction. For a first order reaction, we know that n value, it is equal to 1. N value, it is how much? It is 1. So when I substitute it as I will substitute the value as 1. So it becomes 1 minus 1. 1 minus 1 is 0. Any term to the power 0 means it is 1. So T half, it is what? It is independent of initial concentration. Independent of what? Initial concentration. So in the case of zero order reaction, it is directly proportional to initial concentration. For a first order reaction, when we substitute n value as 1, we will get T half, it is what? It is independent of initial concentration, or it does not depend upon initial concentration. Let us check it for second order reaction. Substitute the value, that is n, it is equal to 2. Substitute the value of n, it is equal to how much? it is equal to. If I substitute the value of n as 2, then it becomes what? T of proportional to R naught power 1 minus 2. Correct. It is 1 minus 2. Here I will write. See, T of proportional to R naught power 1 minus 2. 1 minus 2, it is minus 1, proportional to R naught power minus 1, or T of it is inversely proportional to R naught. Inversely proportional to R naught. So, for a zero order reaction, it is directly proportional to R naught, that is initial concentration. For a first order reaction, T of it is independent of initial concentration. For a second order reaction, half-life period, it is what? It is inversely proportional to initial concentration. For a zero order reaction, it is directly proportional to initial concentration. For a second order reaction, it is inversely proportional to zero order reaction. But for a first order reaction, half-life period, it is what? It is independent of initial concentration. Hope all these things are clear for you. Thank you.